Hello, welcome to Notes 9.03. All right, today we're going to be looking at segment theorems. So I'm going to start actually with the yellow sheet that you have, or the circles cheat sheet. Okay, the front side is all your angle rules. That's going to be Notes 10.04. I'm sorry, 10.04. Excuse me, 9.04. 10.04 last year. Okay, so that's going to be Unit 9. 0.04, which is going to be later this week or next week for you. We're going to be on the back page today. Right? So these four segment rules are as follows. Two tangents. Segments are equal. So a tangent is a segment that touches a circle at one point. So this is a tangent segment. And there's another tangent here. Those two tangents are always going to be equal to each other. So if I were to label this a P, an A, and an R, AP is always congruent to or equal to AR. Interior segments. So here's a segment connecting 2 points on the circle. It's called a chord. So if you have a circle, it's a really bad circle, but you're connecting 2 points, A and B, this segment is called a chord that goes through the circle. But if you have two chords that intersect, they are broken into 4 parts. So this part from here to the intersection, I'm going to call part A. From that intersection to the other point on the circle, we're going to call B. This segment from here to here, let's call that C. And from here to here, call that D. The rule is that those 4 parts, the product of one part, meaning multiply, equals the product of the other 2 parts. So in our picture, we're going to have A times B equals C times D. We're going to look at a few examples on Notes 903 in a moment. Okay, so that's interior segments formed by chords. Exterior segments. We're going to look at the outside times the whole equals the outside times the whole, or abbreviated, ow. So O times W equals O times W. So looking at this diagram, this segment that touches the circle here to here is a chord, and then it extends outside the circle. That segment is called a secant. So if I draw a circle here, so again, connecting 2 points in the circle is a chord. But when you extend the chord, the segment from A to C, if that's a B there, okay, AC is called a secant. Can't you see it? So AC is a secant. So when we go from here, A, let's label that B and C, and I'm going to come back through. There's another secant here, C, D, E, right? There's inside pieces, which are chords, and outside pieces, which we just call the outside part. But the rule says the measure of this outside, CB, times the whole secant's measure, CA, equals the measure of this outside piece, CD, times its whole measure, CE. So we have the outside times the whole thing, the outside times the whole. And there's sometimes some addition needed happening there. So if this inside measure was 8 units long from A to B, and we didn't know the outside measure was X, that whole thing is X add 8. Okay, so sometimes we add up the pieces. The other rule here is the tangent squared equals outside times whole. So if we have a tangent connected to a secant, can't you see it? Okay. These two segments, we take the measure of the tangent squared equals the outside part times the whole part. And we're going to come back to that in our notes today. Just a little refresher from Notes 9.02. So again, segment theorems are 9.03 today. From 9.02, we did our circle equation. So x minus h squared plus y minus k squared equals the radius squared. we pull out the center as an ordered pair, and we take the square root to find the radius. So if I was given this equation, what is the center and radius of x minus 4 squared plus y plus 8 squared equals 16? Your center would be 4, negative 8, and your radius is the square root of 16, or just 4. Second example, x squared plus y squared equals 15. There's nothing added to x and y, so the center would be your origin, 0, 0. And again, we take the square root of the right side, the square root of 15. We're just going to leave it as a radical. To write an equation with the center of a circle, with radius 12, center of negative 4, 0, we're going to put a set of parentheses squared plus a set of parentheses squared equals the radius. 12 squared is 144. I'm going to take that 12 and automatically make it 144. But our center, negative 4, 0, becomes x plus 4, and y has nothing added to it, so we're just going to leave that there. These next two examples I do want you to try on your own. So you have an example there. That's some practice with completing the square. So in this one, you would need an x box, b box. And here it looks like you need an x box, b box, and a y box, b box. And that's all I'm going to really have for us on the yellow page to begin with. All right. So again, we filled in a couple pieces. We're going to come back. We're going to do the front on the next page. So, starting notes 903, intersecting chords theorem. So again, we have two chords, one here and one here, intersecting at a point. Happens to not be the circle. So again, if these two chords intersected at the center, these would all be the radii, and they're all going to be equal to each other. So we have just two segments not intersecting at the center. The segment piece times the segment piece equals the other part times the other part. So across one of my chords, we have an A and a B on this one here. We're going to multiply those together to get A times B equals the product on the other chord. Let's see if you can tell this is there. The product of parts on the other chord would be C times D. So looking at exercise 1, we have two examples of the same kind of case. Find the length of DE. So find the length of DE. So here it tells us C to E is 6. E to D is what we're finding, so we're going to put X there. That's what they asked us to find. AE is 10 and EB is 9. So we're going to take the two numbers across one chord from A to B and multiply those together. 10 times 9 equals the product of pieces along this chord are 6 and X equals 6 times X. So there we get 90 equals 6X. Divide both sides by 6. And 90 divided by 6 gives us 15. So X equals 15, or we would say DE is 15. That's a segment. Same with part B. So again, B is the same diagram, just new segments drawn in. So we have 4 and 9 as parts on one, 6, and E to D is going to be what we're looking for. So remember to put your X in their picture. So we get 4 times 9 equals 6 times X. 36 equals 6X. And dividing, we get, again, X to be 6. So that segment DE would be 6. Easy start. Now we're going to take it up a notch. Exercise 2, in the accompanying diagram of circle O, and we know it's aimed on the center, we have chords A, B, and C, D intersecting at a point E. We're going to mark up the picture with the 4 pieces they give us. If AE is a measure of X, EB is that measure plus 1, X plus 1, CE is X subtract 1, and E to D is twice X, we have 2 parts on the same chord and 2 parts on the other chord. We're going to set up a product of their pieces. So AE times EB are the 2 pieces across the first chord equals CE times DE. So making the substitution, we have x times x plus 1. Now, as I substitute, I'm putting this binomial in parentheses. That helps me with my distribution in a second. Equals 2x times x plus 1. Distribute. X times x gives you x squared. X times 1 is plus 1x. Equals 2x times x is 2x squared plus 2x. Now, I already see myself having a typo there. Let me go back a second. The second one was an x plus 1. My apologies. The second one was x minus 1. So we're just going to change that to subtraction. So from here, we have x squareds on either side. We need to kind of loop them across. So I'm going to subtract x squared and 1x from the left side. What that does is it combines all my like terms. So we have a 0 here equals 2x squared minus 1x squared is going to be x squared. Negative 2x minus 1 is negative 3x. This is a binomial. Some of you are going to be like, how do I solve? This is going to be a GCF case. Okay, so GCF meaning greatest common factor. So an x can be factored out. You're left with x subtract 3. Then we do our t-chart to set each factor equal to 0. So x is 0. X minus 3 equals 0 gives me the other x value is 3. And we know these can't be lengths of 0 or negative 1 if we took 0 minus 1. So in our circle, I kind of resketch what we're looking for. AE is going to be the x value of 3. EB is x plus 1 is going to be 4. Twice 3 is 6. And 3 minus 1 is 2. Is 3 times 4 equal to 6 times 2? Yeah, it'll check out. So find AE. AE is our x value, will be 3. Back into the picture. So again, product of the pieces. So when you're trying your classwork today, you're going to see this picture, see what we did when you're looking at the diagrams here. So notice this picture would be like numbers 1 and 2. So I'm going to say with this one, C number 1 and 2. So I want you making those connections as you're trying your classwork. All right? That's note 903. Two tangents. Okay, two tangents from the same exterior point are always equal to each other. So if that measure is 18, this measure would be 18. So solve and find all values of x. So looking at this question, we have across one segment, AB is x squared plus 8. The other tangent is 33. And we know they're tangents because there's just one point of intersection. We're going to solve. To get x alone, we subtract 8 from both sides. X squared equals 25. Technically speaking, when we take the square root, we do get plus or minus 5. However, we said for all values of x. Technically, negative 5 can be plugged back in and always become a positive. So if I put in negative 5 squared plus 8, I'm going to still get 33. So we're going to keep both answers here. We're not rejecting any negatives because when subbed back in, either answer will always become back out to a positive. So again, two tangents to the same from the same exterior point are equal to each other. So that would be similar to, there isn't any two tangent questions over there. We'll come back to those. Okay. Secant, secant, tangent, secant. So each of these pictures are a little bit different. So two secants, again, is a circle with a chord that's extended outside the circle with another chord that's extended. So we kind of have some arcs here. O and W stand for outside and whole. So what this stands for is the outside segment of your picture, represented really by B here, times the whole thing is the sum of those two pieces would be A. So this would, substitution would say B times A equals the outside piece D times the whole thing C. So outside is what O stands for, and the W stands for the word whole, W-H-O-L-E. So that's going to be like exercises 4 and 5. Okay, so these are both the double secant rule. Okay. The tangent secant theorem is going to be like exercise 6. Okay, so this has a tangent and a secant. Can't you see it? So we're going to come back to that one in a moment. So looking at exercise 4, we're going to go off of this outside times whole and outside times whole. So there's a product of two sets. The accompanying diagram, secant AB intersects circle O at D, and secant AC intersects the circle. So that sentence told you it was two secants. So we're looking at ow, ow. Marking up the diagram. Just gonna grab my pencil. It's kind of a small picture. If AE is 4, that's an outside part. AC, A to C is the whole secant is 24. AB is 16. That's your whole segment on this side is 16. Find AD. So we're looking for that outside part. So AD is the outside. AB is a whole segment. AC is a whole segment. And AE was an outside part. So we're going to take these two measures as a product on one side equals x times the 16 on the other. So the outside part is 4 times the whole thing, 24, equals the outside x times the whole thing, 16. So 4 times 24 gives us 96 equals 16 times x. Divide by 16 and we get x to be 6, which tells us AD is what we're looking for, equals 6. How's exercise 4? Exercise 5 takes a little bit up a notch. So in the accompanying diagram, circle O, secant AB intersects circle O at D, and secant AOC intersects at O. Oh, circle O intersects O. That center at O, see here, it kind of doesn't pass through it. Here, this secant AEOC goes through the center. That tells us, remember, EO and OC are radii. So those two segments are equal to each other, from E to O and O to C. If AE is 4 and AB is 12, that's the whole one over here, and DB, the inside part, there is 6, so that's a chord. Now I do need to do a little subtraction. If the inside piece is 6, then the outside piece is going to be 6, because I know I need the outside for my rule, the outside part. So I needed to solve a little bit for that 6 first. Find OC. Now OC is part of this whole diameter. Now I'm going to write out the rule. Outside times whole equals, outside times whole. I have this outside, the 6. I have the whole thing, 12. So I'm going to kind of sub those in to start with. I have this outside piece, 4. I can find the whole thing, x, pretty quickly. 6 times 12 gives me 72, divided by 4. The whole measure here is going to be 18. So we know A to C is 18. Well, A to E is 4. They're asked for OC. So if I know the whole thing and I have a 4 outside, I know that my diameter, this chord on the inside, is going to be 14. 14 and 4 adds to 18. So we're going to get that OC is half of that is your radius to be 7. So you have to be careful on what parts they're looking for. I kind of set up my equation based on the rule. Then I went back and did some subtraction to get what I needed. Let's see how to think. Exercise 6 is a little different. This was the tangent and the secant. So I'm going to go back up to the top of the page here and talk about the tangent secant rule. So remember, your tangent just touches the circle at one point. The secant comes through and touches your circle in 2 places. What we have to do is take the measure of the tangent squared. So if this segment, let's call this point A, point B, point C, and D. So A, B, C, D are the 4 locations of those segments. The tangent is segment AB. You're always going to take that measure squared equals the outside part of the secant, AC, times its whole measure, AD, for that diagram. So the tangent squared, so you need you need a product on this side. You're multiplying 2 things over here, same measure times itself, and 2 things over here. Okay? That's the general idea with all 3 of these rules. We're multiplying, for the chord theorem, we're multiplying 2 things and 2 things. So looking forward to exercise 6, if P to S, again, PS is my tangent, that's X. PQ is the outside part there, is 3. And PR, the whole thing, is X plus 18. Our rule says that the tangent squared equals the outside times the whole. So the tangent measure was represented by X. So we take X squared equals the outside part, 3, times the whole thing we represented by X plus 18. And this is where your algebra skills are going to come in. We get X squared equals 3X plus 3 times 18 is 54. We need to set this side equal to 0. So again, we need to make our trinomial happen. So we're going to subtract our 3X over and subtract 54. So we get X squared, subtract 3X, subtract 54 equals 0. I could have completed the square if this 3 was an even number. Okay? You guys, we've been practicing that a lot, to complete the square. So we could have done it here, but we need to be thinking that number puzzle. So if I bring up my number puzzle, what multiplies to negative 54 and adds to negative 3? If you need your calculator trick to help you out, factoring will be part of your final exam. 54 divided by X, go into your table, decide which set of factors adds to negative 3. I believe it's going to be a 6 and a negative 9. So we get positive 6 and negative 9 to be the factors. Sorry about the interruption. So we get X plus 6 and X minus 9. Some of you find these and you think you're all done. Those are the factors. The solutions come from there. We swap the signs. X is negative 6 when we set H equal to 0, and X is 9. So in our case, we're going to take the 9. We're rejecting the negative 6 because, again, we're talking about the measure from R to S. It has to be a positive measure. So what is the length of PS? PPS, postscript, PPS? Yeah. Sorry, kind of like writing a letter. We're going to jump over to the classwork. So, question 2 is a tangent secant. You know, that's all new for us. So you have a tangent to here. This segment would be a secant. Refresher on the whole secant. The entire measure from A to this endpoint here is X add 5. Okay. You will get a quadratic there. You're going to have to factor for number 2. All of these require a little factoring. Okay. Same thing with number 3. That's the secant rule. So I'm going to write outside times whole equals outside times whole. Outside times the whole thing. Outside, we don't know the whole thing yet, so you're going to want to find that first. Okay. So I should see some equations solved off here to the side. Number 4 is a word problem. Okay. You really have to read it to describe where the G, the L, the D, and the B stand for. So you have some cabins, B and D, a circular lake with the cabin L for a lot, and D is a dot. All right, so try what you can on number 4, kind of applying the idea. Exercises 5 and 6 are using this picture, and there's actually 3 things going on here. If I kind of cover up some of this, okay, you have two chords intersecting. So you want to break up your diagram to see the 2 chords that intersect with the measures you're given. And then also, if I cover up FC for a second, you have the 2 secant rule, okay, where 2 things come outside your picture. Okay. So there's 2 rules kind of overlapping in that diagram, all right? Question 5, you're going to use that picture. For some of the segments, then you're going to want to cross those out and redraw it. Or if you want to redraw it yourself at the beginning so you don't confuse numbers from one part with the other part, you might want to do that. Okay? So I would redraw the same diagram to help yourself with number 6. Number 7, same idea. There's a part A and a part B. You do need this answer for that answer. Okay, so these are kind of independent from each other up top. This, you need one answer to help you with the next. Want to see what you can do with it? Try your best. Again, remember you're really multiplying 2 things on one side of the equals and 2 things on the other. Here you have the outside times the whole and the outside times the whole. Happy solving. Have a great day. We have one more notes page to go.